So this is going to be an example problem using almost all possible steps for your basic high school stoichiometry. So in this particular problem, we're first asked to balance the equation. Now notice we have a polyatomic ion here, which we know it's polyatomic because there's more than 2 capitals in the compound. Same here. 3 capitals means there's got to be a polyatomic. So we have an NO3 on this side. And we want to look and make sure it's still NO3 over here. As long as it didn't break up, then we can count them as whole things. And then we check the other polyatomic. OH, we still have it as OH here. So we can count them as wholes. Now on the left side of the arrow, we have 2 nitrates. Over here there's only 1 whole nitrate, which means I need a coefficient of 2 here to give me 2 nitrates, 2 nitrates. But when I added this 2, it changed my Na to 2Na. Which means I need to have 2 sodium on the left. So I need to add a coefficient of 2 there. Now when I check my OHs on the left, that now also gives me 2 whole OHs. I already had 2 whole OHs. Then I have 1 Ni and 1 Ni, so it would fill in the coefficient for each. So in part B it says if you have 750 grams of each reactant, how many moles of each do you have? So we're starting with 750 grams of each reactant. Remember the reactants are water on the left side of the arrow. Now notice that decimal, I'm keeping it. That decimal is important because it is telling us that that value of 750 has 3 sig figs, not 2. Now before we can change the grams of something to moles of something, please remember that means we are using our mole heart, which my class did back in October-ish. So if I want to go from grams to moles, I already know from previous videos that the number of grams, the molar mass, will go on bottom, and the 1 mole will go on top. And if I am in moles, and I'm going to go 2 grams, then the 1 mole will go on bottom, and the number of grams will go on top. So please remember that this particular number next to the gram is your molar mass. And if it's a regular element, like if it was just 1O, 15.999 would be the number of grams in 1 mole of oxygen. But we don't have singular elements. We have compounds. So we're going to kind of pull over to the side. And remember, if we're calculating the molar mass of a compound, we have to count each part, multiply, add it up. So if we break down this compound, we have 1 Ni, because there's a subscript of 1 in there. So we have 1 nickel, plus the 2 distributes within the parentheses, so 2 times 1, we have 2 N's, and then 2 times 3 is 6, so we actually have 6 O's in this compound. So nickel is right here, so the molar mass for that 1 nickel is 58.693. Okay, so then for the nitrogen part, I see that nitrogen is 14.007. Now since there's 2 of them, I'm going to put in parentheses. I'll do 2 times 14.007 for the nitrogen part, plus the oxygen part will be 6 times the molar mass of O, 15.999. Now, if you use your parentheses and you put this in your calculator straight, just how it looks, 5.693 plus parentheses, 2 times 14.07, close parentheses, plus parentheses, 6 times 15.999, close parentheses. When you put that in your calculator, it gives you the molar mass of 182.701 grams per mole. But we have 2 problems, so we're going to go ahead and find the molar mass for the other compound. Now the other compound has no subscripts next to any of the elements, so we have 1 sodium plus 1 oxygen plus 1 hydrogen. Now the molar mass of sodium is 22.990. I know that because it's the number in the bottom box of sodium. And then we already saw that the molar mass of oxygen is 15.999. And if we look, hydrogen has a molar mass of 1.008. So when we add all those numbers up, we get a molar mass of 39.997 grams per mole. So once we have our molar masses, then we can do our grams to mole math. Now, because we are in grams, we're going to get rid of grams. Based on our mole heart, we'll be putting the molar mass number on bottom. So for this one, the 182.701 grams will go on bottom, and the 39.997 grams and 1 mole will go on top. So remember, this is essentially one big fraction. So you can think of it that we're doing 750 times 1,